Hi, everybody. I'm Miss Kelly, and I work at the South Bowie branch of the Prince George's County Memorial Library System. Welcome to STEM at Home. Today we have some terrific activities presented by Latarsha Carithers of the Prince George's County Alumni Chapter of the Delta Sigma Theta Sorority. The Deltas have partnered with us to provide STEM programming here at South Bowie for many years, and their programs are the best. They are so much fun. Now we are delighted to have them with us for STEM at Home. So take it away, Deltas.
Hello, everyone. I'm Latarsha Carithers, and I'm a member of the Science and Everyday Experiences, or the C Committee, of the Prince George's County Alumni Chapter of Delta Sigma Theta Sorority Incorporated. I'm very excited to be here with you today, and we'll be walking through two different science experiments. So let's go ahead and get started. The first science experiment is called Walking Water, and I'm going to show you what materials you need. You're going to need food coloring. I prefer the colors yellow, blue, and red, but you can use any colors. You'll also need 5 clear cups or glasses, like these. You'll need a ruler, scissors, a spoon, paper towels, and you'll need water. Tap water is fine. So to start, you'll set your cups up in a row, and you want them touching each other. And then you'll fill every other cup with water. So I'm going to fill the first cup with water, and I want to fill it all the way up to the top, or almost all the way up to the top. So it should look like this. Okay, next I'm going to add 1 food coloring color to each of the cups that have water in them. So I want yellow to be in the middle cup, and then red and blue will be on the end. I'm going to add 8 drops of red food coloring to 1 cup. Okay, I'm going to add blue food coloring to the other cup at the other end. So 8 drops there as well. 1, 2, 3, 4, 5, 6, 7, 8. And then for the middle cup, I want to add a little bit more yellow than I did the other color. So I'm going to add 10 drops of yellow there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there we go. Now I'm going to take my spoon and I'm going to mix the colors in the cup. I'm going to start with the lightest color, which is yellow. I'll stir it. Then I'm going to take a small piece of paper towel and I'm going to wipe the spoon before I go to the next color, which is red. I'll wipe the spoon again, and then I'll go to the last color, which is blue. Okay, now our food coloring is mixed into the water, and we're going to want to get our paper towels. So I need 4 half sheets of paper towel. And I'm going to fold each half sheet the long way once, like this, and I'm going to fold it again. And I'll do this with the other 3 pieces of paper towel as well. Okay, so now I've folded all 4 sheets of paper towel. Now I'm going to use my ruler. What I want to do is I want to measure the height of each cup. They should all be the same height, so you really only have to measure 1 cup. So my cups are 3 inches tall. I'm going to multiply that number by 2. So for me, that will be 6 inches. For you, it could be different because your cups might be a different height. And then I'm going to add 1 inch to that. So for me, the total number is 7 inches. So then I'm going to measure 7 inches of paper towel and cut at that point. I want each paper towel to be 7 inches long. And it doesn't have to be perfect. Okay, so then this is 7 inches here. I'm going to fold it in half, and I'm going to place one end of the paper towel into a cup with water and then another end into a cup without water, just like this. And I'll do this until each cup is connected. Okay, so do you notice anything immediately? Are there any observations that you can make? For me, I can tell that the paper towel that used to be dry is now wet. I can also see that the paper towel now has coloring on it. So the paper towel that went into the blue cup, it looks like it's now a blue color. The paper towel that was in the yellow cup is now a yellow color. And also the paper towel that was in the red cup is now a red color. So what do you think is going to happen? Do you think that the water from one cup will move into the empty cup? What if the water does move from the cup where we originally had water into the empty cup? What do you think will happen? Do you think that water will only move from one cup or from both of the cups on each side adjacent to the empty cup? What do you think will happen? I want you to write down your hypotheses, write down what you think will happen, and then we're going to wait overnight and see what happens. So luckily for us, I actually set this experiment up last night so I can show you what happens. Okay, so this is what your experiment will look like the next day. So what I can immediately notice is that the cups that originally did not have any water in them, they now have water. I also can see that the cups where I originally placed water, the water level used to be very high. It was almost to the top of the glass or cup, but now it's only about halfway high. So to me, looking at this, I believe that the water moved from the cups that originally had water in them into the cups that didn't have water. One piece of evidence that I have to show me that this actually happened is that for the cups that didn't have water in them originally, if you look at the color, these are colors that we didn't use originally. So the cup in between the cups that had blue food coloring and yellow food coloring, it's now green. The cup that was empty, but between the cup with the red food coloring and the yellow food coloring, it's now orange. So I know that with my primary colors, red and yellow make orange, and blue and yellow make green. So this to me tells me that the water came from the adjacent cups into the empty cups and mixed. So why does the water move between glasses? You won't be able to see this with your bare eye, but each cup has millions and millions of water molecules. These water molecules should not be able to move up the paper towel because of the force of gravity. Now, what's gravity? if you think about when you jump in the air, when you jump in the air, gravity is the force that pulls you back down to the ground. So when you jump, you don't just continue floating into the air, it pulls you back down to the ground. So the same thing should happen here. The water shouldn't be able to go up because the gravity will pull it back. However, there's an invisible force here, and that force is adhesion. So the water molecule is attracted to the paper fibers, and that force is called adhesion. So another thing that happens is that the water molecules are also attracted to other water molecules. So first, the first water molecule comes and says hello to the paper towel. They like each other, and then they start to go up. But that one water molecule is lonely, and it likes its friends. So it also brings along the other water molecules, and they start to go up the paper towel, and that is called cohesion. So these two forces together are referred to as capillary action. So what are some real world references to capillary action? So plants use capillary action to pull up water and nutrients from the ground. So if you compare a plant to a human, for humans, we have hearts that pump blood throughout the body, and that allows us to get nutrients and oxygen all throughout our body, spread the blood all throughout our body. However, plants do not have a pump, so they depend on that capillary action to pull up water from the soil, and the water spreads to the stem and spreads to the leaves, and that's how it gets all its nutrients and water from the ground. Another example is if you go to the doctor. Sometimes they have to run tests on your blood to make sure that you're okay. So they'll prick your finger and a little drop of blood will come out, and they use a tube called a capillary blood tube in order to collect that blood and run tests on it. So those are real world examples of capillary action. So I want to just thank you for joining me today. I hope that you had a lot of fun. It may have seemed easy, but you actually learned a lot of very complex ideas about physics, such as cohesion and adhesion. So congrats on a job well done. Thank you. The next experiment that we'll be doing is actually making a mechanical hand. So I'm going to first walk you through the materials that you'll need. You'll need some construction paper. Any color is fine. You'll need 5 straws. You'll need scissors, a ruler, a marker or pen, some tape, and string or twine. Either one is fine. So to start off, I'm going to place my hand, well, actually, I want you to place the paper landscape in front of you, and then I'm going to place my hand on top of the piece of paper, and I'm going to outline my hand. Now, if you have a small hand, you probably want to make your outline much bigger because you really want it to take up almost the whole length of the paper, and I'll show you what I mean. So I'm going to take my pen and trace my hand. And you want to make sure your fingers are spread out. So it looks like this. It almost takes up the whole height of the paper. And what I'm going to do is in the wrist area where there's nothing, I'm actually going to join those 2 sections. I'm just going to take my pen and loop them together. Next, I'm going to take my scissors and cut out the outline of my hand. And it doesn't have to be perfect. We just want to see the general shape of your hand. So this is what my hand looks like. Next, you can decorate your hand however you like. So you can put fingernails on it, you can put rings. So I'm just going to very quickly add some fingernails to mine. And I'm going to add a ring as well. So this is what my decorated hand looks like. Your drawings are probably better than mine. But what you want to do is the side that you decorated, you want to place it face down in front of you. So now you have the side that's blank, upwards. You want to take your straws and your ruler, and you want to measure a 1-inch piece of straw. That's about here. And I'm going to take my scissors and cut that 1-inch piece. Now I'm going to do the same thing for all 5 straws. And it doesn't have to be perfect, so I'm just going to use the first straw that I cut as a template. Okay, now I want to tape these pieces of straw, the 1-inch pieces, to the area of the hand where the fingers meet the palm. So pretty much where your knuckles are. And I can just show you. Let's see if I can point this down. I'm going to take a piece of clear tape. So your hand should look like this. Now I'm going to take my string and I'm going to measure 10 inches of string. And then I'm going to cut 10 inches. And I need 5 pieces, 5 10-inch pieces of string. And I'll just use the first one that I cut as a template. I have my string. Now I'm going to place my hand up in the air and I'm going to point the fingers down and I'm going to just slide the string through the straw. Just like that. And I'll take a small piece of tape and I'm going to tape the tip of the string or twine to the tip of my finger. So just like this. And I'm going to do that for all 5 fingers. It might be easier actually if you lay it down on the ground, whichever one is easier for you to put the string through the straw. can use whatever technique works best for you. Okay, so this is what my hand looks like now. All of the pieces of string have been taped down to my fingertips. Now I'm going to take those same pieces of straw, those same straws, the long pieces that you have left, and I'm going to measure 3 inches this time. So 3 inches is about here. Okay. And I'm going to put 1 piece of 3-inch straw through each of the strings, or put the string through each straw. So you can see that the string has now come out through the end. And I'm going to do this for each straw. Okay, so this is what it looks like so far. And what you'll do is you'll take a longer piece of clear tape. You'll line up those 3-inch pieces of straw around the wrist area of your hand. And you'll tape those pieces together to the base of your hand where the wrist is. All right, so now you have a mechanical hand. And you can play around with it by pulling each of the strings. You can see that you can pull a finger down by pulling each piece of string. So let's see if I can make the peace sign here. Peace. I can also try to make the, let's see, and try to make the I love you sign. I love you. So I hope that you had fun. This activity incorporated the engineering arm of the word STEM, science, technology, engineering, and math. And hopefully you can do this on your own when I'm not around. So thank you for joining me today. And on behalf of the Science and Everyday Experiences Committee of Prince George's County Alumni Chapter of Delta Sigma Theta, I just want to say thank you for your time and have a great day.
Thank you, Latarsha. Those were some really cool activities. If you want to do more experiments at home, the library has lots of great books you can order in our catalog and pick up through our curbside service. There are a couple of them I would like to point out today. This first one is called I Can Make Remarkable Robots, and it is by Catherine Holzweiss, and this actually has instructions for making a robotic hand, just like Ms. Latarsha did today. Another great book we have is called Cola Fountains and Spattering Paint Bombs. It is by Jesse Goosens and Linda Fass. And this has instructions for an experiment like walking water. So please check out the catalog to look for some of our great materials. Also, please remember to check the library's website, our Facebook page, and our YouTube channel for more great programs. Bye now.